You have probably heard the prevailing wisdom in the artificial intelligence industry that bigger is better and newer is always superior. When it comes to processing documents, extracting text, and understanding layout, the assumption is that the latest large multimodal models should be the undisputed champions. This belief drives massive budgets and complex architectures. However, a recent comprehensive investigation challenges this fundamental assumption in a way that matters deeply for anyone building production systems. We ran a massive benchmark test involving 18 different large multimodal models and generated over 7,000 API calls to evaluate their capabilities on optical character recognition tasks. The results revealed a surprising performance-cost paradox, where older and significantly cheaper models frequently outperformed their expensive state-of-the-art counterparts. Here is the thing that makes this finding so critical for the industry. In most fields, scaling up parameters leads to scaling up intelligence. But in text extraction tasks, we found that token efficiency and error patterns play a far larger role than raw model size. Many of the large multimodal models scored below 50 out of 100 on standardized benchmarks like OCR Bench V2 and the OCR Reasoning benchmark. These scores indicate persistent failures in fine-grained perception and layout understanding, even when the models possess high reasoning scores on other metrics. It turns out that the ability to reason about complex logic does not directly correlate with the ability to accurately transcribe text from an image. To understand why this happens, consider the difference between a generalist scholar and a specialized scribe. A large multimodal model is like a scholar who knows everything about history, science, and literature, but has never spent years training on the specific art of handwriting recognition. When you ask this scholar to read a document, they might get distracted by the semantic meaning of the words rather than the visual form. They might hallucinate characters that look similar but are incorrect, or they might struggle to distinguish between a letter and a symbol because they are trying to apply general knowledge where none is needed. Older models, often trained specifically on text-heavy datasets, act more like the specialized scribe. They are less prone to hallucination because they have not been overfit to the complex reasoning tasks that often introduce noise into simple transcription. Now consider the financial implications of this discovery. In a production environment, cost efficiency is a decisive factor. Running an expensive large multimodal model for every single line of text in a high-volume pipeline can drain resources quickly without providing a proportional increase in accuracy. The data suggests that for standard text extraction tasks, cheaper models provide a much better return on investment. This is not to say that the large models are useless. They excel in complex logical reasoning scenarios where the text needs to be understood in context, such as interpreting handwritten notes that require understanding the sentiment or intent behind the words. But for the heavy lifting of converting images to text, the specialized older models often deliver superior robustness. There is also a significant knowledge gap regarding the specific performance metrics of these winning older models compared to their modern counterparts. Detailed comparative data has often been fragmented across different benchmarks, making it difficult for engineers to know which model to deploy. This is why the open sourcing of comprehensive datasets and evaluation frameworks is so critical. Tools like VLM EvilKit provide the necessary infrastructure to facilitate such evaluations across hundreds of models. By making the OCR Bench V2 and similar datasets available to the community, researchers can expose the discrepancy between model size and actual OCR utility. This transparency allows developers to make informed decisions based on empirical evidence rather than marketing hype. Furthermore, the research highlights that a divergence exists in focus among current benchmarks. While some research targets static images, others address challenges like occlusion and hallucination in moving video contexts. However, the consensus is clear that traditional OCR engines are still relevant. In fact, hybrid approaches are showing superior robustness for complex layouts. Imagine a system where a traditional optical character recognition engine handles the initial extraction of text, and then a large multimodal model is used only to correct errors or handle the ambiguous parts. This combination leverages the speed and cost efficiency of older technology with the reasoning capabilities of newer models. It is a pragmatic solution that acknowledges the limitations of both technologies while maximizing their strengths. The implications for the future of this technology are profound. We are moving away from a one-size-fits-all approach where every task is routed to the largest available model. Instead, we are entering an era of model specialization where the right tool is chosen for the specific job. This shift requires a deeper understanding of token efficiency and error patterns. It means that when you are designing a system to process invoices, receipts, or scan documents, you should not automatically default to the newest, most expensive model. You should evaluate the specific error patterns of the models you are considering. Does the model hallucinate numbers? Does it struggle with handwritten script? Does it get confused by complex tables? These are the questions that determine success in OCR tasks. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.